Hey y'all, welcome to today's video where we're going to be looking more at slope, which is the letter m in our equations of y equals mx. And we're going to actually be looking at kind of some word problems and how to figure out what the rate of change is given a word problem. Now, before we take notes on this page, I just want to review this real quick. And this is not anywhere on your notes for today, but I just want to review what I mean by saying the words rate of change. So rate of change is actually the same thing as the word slope, and it's the letter m over here in our equation. So if I want to know what number needs to go here in the equation for the proportional table of values, you could look and see if you can just identify what number needs to multiply to get each of these. And I think a lot of you are going to spot with this one that it's a 4, 3 times 4, 2 times 4, and so on. So we can get the equation y equals 4x by just looking at the table. But the rate of change is technically found here when I go from this point to this point to this point to this point. Here I'm going up by 4. And the x values are changing by 1. So the rate of change is this number over this number. And 4 over 1 is 4. So this all lines up, okay? Now on the coordinate plane, let me just real quick make an x and y axis. Without actually straight up plotting all of these points individually, I'm just going to come over here to the coordinate plane and say, okay, everything that's proportional goes through the origin. And I'm going to use my rate of change. My y values should go up by 4. So I'm going to go up by 4 on the y-axis. And then on the x-axis, I'm going to go over 1. So I'm going up 4 over 1. Up 4 over 1. And you can just assume this is like a 1, 2, 3, 4, and then 5, 6, 7, 8. And you can see here I just went over like 1 and then another 1. So this is the up 4 on the y-axis, which is right here. And then this is going over by just 1, which is right here on the x-axis. We have our x and our y-axes here. So the rate of change is the staircase, or this thingy over here off to the side in the table of values. And it's also just known as the slope, or m, over here in the equation. Slope, real quick, kind of means like steepness. So 4 over 1 is different than like if we did a 1/4. That one would not be nearly as steep if we go up 1 over 4. So that's what I mean by slope, is just kind of how steep the line is. And now I think we're ready to come back over here, all right? Now, in our previous unit, we did see something that looked like this. We talked about problems where we needed to set up a proportion. So for example, if it takes him 5 minutes to read 3 pages of Wonder, I can put that in table of values. And I can use this ratio over here. I'm going to put minutes up top. We'll put pages next, just because it came second in the problem. And we're saying that it takes him 5 minutes to read 3 pages. The problem goes on to ask, how long will it take Javier to read a chapter that is 18 pages? So over here, pages was down in the denominator. So I'm going to put the 18 pages down here. And what we want to know is right there, how long would it take? Now we do know how to solve a proportion. We cross multiply and divide. So if you do 5 times 18, that's a 90. And then if we do 90 divided by this 3, 90 divided by 3 would be 30. So this over here would be a 30. And we can actually also see it here. Some of you might catch that 3 times 6 is 18. So 5 times 6 should be the 30, and it all lines up, it works out there, okay? So what I'm going to do now is I'm going to come over to the table of values, and I'm going to say that we just calculated that in 30 minutes, Javier would have read 18 pages. Now we have a table of values because obviously this is an entire book, and so like Javier could read for an hour. And if in half an hour he reads 18 pages, I can say, well, in double the amount of time, it should be double the amount of pages. So then this would be 36 pages. Okay. So that's how the table of values can show these proportional relationships. It just continues to show lots of possible different scenarios within this whole setup. Okay. So I'm going to leave this last one blank for right now. I'm going to do that on purpose. And now let's kind of explore what these questions are going to look like in this current unit. This is how it looked back in unit 2. And now this is going to be the setup here in our current unit right here. Let me actually put up a screen shade as well so that we're only looking at one particular problem at a time. Okay, here we go. So in this question, it's the same thing. It's still telling us that it takes Javier 5 minutes to read 3 pages of Wonder. And this time it's just starting to kind of gear you up a little bit for algebra. This is saying, so if it was a table of values, X is going to be the minutes. And that is like up here. And it's saying if we had a table of values, Y would be the pages. That's right here. And then it just wants you to straight up complete this sentence. At this rate, Javier will read blank pages in a minute. So we want to know basically how many pages he's going to read in 1 minute. So this seems kind of confusing. All it's saying is that if you were to put a table of values together, that it would look like that. But the setup is still the same. 5 minutes to read 3 pages. That's the same as what we did right here. Now, if minutes is in the numerator, we're going to put 1 minute right here. And then this time, our unknown is how many pages it would be. Remember, we put minutes up here, 5 minutes for 3 pages. So in only 1 minute, how many pages? Now again, we can just cross multiply and divide. So this time I'm going to do 1 times 3, and I get a 3. And when we do 3 divided by 5, y'all, 3 divided by 5 is that 0.6. It's a 3/5. So it looks like in only a minute, Javier wouldn't finish a full page. He'd finish 3/5 of a page, or 0.6 pages, 0.6 pages. Now in the table of values, we can now put that answer in here. We can say that if 1 minute were to go by, I put a 1 right here, I can put a 0.6 right here. And even though we don't have the pattern on either side, it doesn't matter because we didn't go in any particular order. We just tried out 5 minutes, then we said 30 minutes, then we tried 60, and then we went back to a minute. But this is a table of values that shows the relationship between each of these. And it looks like right here that in 1 minute, Javier will read 0.6 pages. All right, so now this has nothing to do with the book Wonder anymore. This is just, it's a brand new problem. And I'm going to put that screen shade back up. I just wanted to see how much more I had left on this page. All right, here we go. So we're looking at the problem now about Tyler riding their bike for 40 minutes. And after 40 minutes, it looks like Tyler has traveled a distance of 5 miles. All right, so over here, we've got the number of miles and the number of minutes. And at this rate, we want to see Tyler will ride blank in blank. So we don't have anything to put over here yet. Up here, it already gave us 1 minute. So we put that there. And we had something to put in the table of values here. In this problem, we won't have anything to put in the table of values. And the reason we don't have it here is because it gives us some options. So if you ever see a problem like this, y'all, where it's actually straight up going to make you figure out the miles and the minutes, look at my strategy with this table of values. Go ahead and just put in 1 mile right here. And we're going to put in 8 miles right here. And we're going to see using this ratio, we'll see how many minutes it would be for 1 mile. We'll also see how many minutes it would be for 8 miles. And then what we'll do is we'll pick and choose the ones from here that need to go into these blanks, okay? So Tyler's on a bike, 40 minutes goes by, and he's been able to ride 5 miles. So what I'm going to do is I'm going to right here underneath, I'm just going to set up a proportion. We've got 5 miles. Well, we can do minutes first. We'll do minutes first. We'll do 40 minutes over 5 miles. All right, let me get rid of that. And I'm just going to, again, I'm putting minutes over miles here. So I've got minutes over miles. So 40 minutes to ride 5 miles. And now we're going to see how long it would take to ride 1 mile. That's going to be us right here, putting in the 1 mile and seeing how long it would take. Now, if we cross multiply right here, 40 times 1, it's 40. And if I do 40 divided by 5, I get an 8. So it would take 8 minutes to ride 1 mile. Now I have that as an option, so I could fill in the blanks already with that. I'm going to set up the other proportion for 8 miles just to check. Again, we're going to use the 40 minutes, 5 miles. Let's see how many minutes to go 8 miles. And that's me just checking out this possible answer right here. So if I do 40 times 8, that's 320. And now I'm going to get my calculator out to do the 320 divided by 5. So we got 320. We're going to divide it by 5. Okay, we get a 64. Now to go 8 miles, if I were to put that in the blank up here, I need something that says 64 minutes. So I am now going to eliminate 8 miles because I know I don't see 64 minutes. Whoops, I don't want to delete that. I just know that 8 miles, I don't see 64 minutes. Now for 1 mile, we said that it was 8 minutes. So those are going to be the things that we use to fill in the blanks. So at this rate, it looks like Tyler will ride 1 mile in 8 minutes. So the reason these problems are kind of annoying, y'all, is because it really does kind of look like it's like a guessing and checking situation. You've got to try a couple things out to see which one will work. And a lot of times when we're in a math class, we don't like it when the problems are like that. We just want to be able to do one thing and get the answer. So I can totally understand why this is kind of annoying. But again, there it is right there, 1 mile in 8 minutes. All right, now let's try another one. Okay. And as I'm looking at this, I'm realizing I think for both of these, like the table of values, X is miles and Y is minutes. So we need to put that Y is minutes and that X is miles. And again, in the table of values, let's just make sure it lines up. X over here should be miles. So I need to put that the X represents the number of miles. And we'll put here that Y represents the number of minutes. That's not that big a deal to pull off that little switcheroo. That's fine. But you can see again, just based on that in 10 minutes, that 7 miles were driven. And we've got these blanks. And so basically what we need to do is, again, we need to say, okay, so if we're going to be looking at minutes and miles, 10 minutes, he drove 7 miles. So then what we want to know is, if I plug in a 0.7 for miles, I'm going to put in a 0.7 right here. And I'm going to solve. And I can also try by putting a 1. So let's do the same ratio. I got a 10 to 7. And I'm going to try out 1 mile and just kind of see which pair works. So again, for miles, I'm trying the 0.7. And then we're going to try for 1 mile. And we're going to see what the answers are and which one of these works. Okay, kind of which set it would be. All right, so if I multiply here, I'm going to get a 7. 10 times 0.7 is 7. And if I divide it by this right here, if I divide by 7, I'm going to get a 1. Okay, so when I solve this proportion, I get a 1. Now let's solve this proportion. Here, I've got 10, and this 10 is going to be divided here by the 7. So when we do 10 divided by 7, let's round that to about, let's do 1.4. So this would be a 1.4. So if we did 7 miles, it was 1 minute, and that answer is right here. So we can put Tom will ride 7 tenths of a mile in 1 minute. And all this is saying, y'all, if we picked the 7/10 of a mile in 1 minute because of this solution right here, we're basically just saying that it is 0.7 times x. That's kind of the rate of change. We're just saying 7/10 for 1 mile. So when we've been looking at these problems so far, we've been looking basically just at table of values without any words around them. When you guys see problems like this, you can just use the table of values to kind of guess and check and see which of these options should fill in the blank. You could have put in an 8 mile here if you wanted to, but then the answer in minutes isn't there. So that's why I just start with these first two and set up the proportions with those and try to find the right minutes in the table so that I can pick which one it is here. Now you guys are going to try here on your own. There's no table of values, as you guys can see on either of these right here. So if you want to pause the video and just try to read these problems without a table of values and see if you can do it without the table, go ahead and pause it and just read them and try. But right now what I can do for you guys is kind of show you real quick. This would be for page 13 here. It says, let's see, we've got X represents the number of minutes. So in a table, I've got X and Y. So it says X, let it be the minutes. So you'll put that here. Y would be pages. So that's going to be on this column. So we're getting our table kind of set up here. And I just wanted you to kind of see it with the words or with just X and Y. And the first ratio it tells us is that it takes Maggie 12 minutes to read 6 pages. Now I think a lot of you are already going to see like a half situation going on. But again, in the table of values, we want to now try. Okay, let's see right here. See how the table is set up? All right, you can put the 20 pages and the 10 pages. If you put that in the table of values, the 20 and the 10 would go here. And we just need to see what the answers would be right here for minutes on this side. So I'm going to use my 12 over 6, the thing that was given here, 12 over 6. I'm using that, which means I'm putting minutes over pages. Okay, cool. And if we're going to go with the 20 pages here and the 10 pages here, pages is in the denominator, so I'm going to set one up for the 20 and figure it out. And then we'll also do it all over again and set it up for the 10 pages. And basically only one of these answers that's going to go in the table is going to match up with this. Now a lot of you see that 12 gets cut in half to be a 6. So 40 would get cut in half to be this 20. So this answer right here is a 40. Okay. And over here, once again, if 12 gets cut in half to be this 6, oops, there we go, then 20 is the answer right here that gets cut in half to be the 10. So here's a 20. So again, we can see the rate of change in the table of values. This rate of change is the 1/2. And right here, it looks like I don't see 40. So 40 is not anywhere. So I can't pick this one. Looks like Maggie will read 10 pages in 20 minutes. And if you don't believe me, that's this answer right here. We said 10 pages in 20 minutes. Okay? All right. So again, this is going to be an annoying unit simply because you've kind of got to guess and check and play around with what's going to go in here. But the good news is you only have 4 possible things that could go into these blanks. So even if you tried all of them, like you could put this one in here and check for its answer. You could put this one in here and check for its answer. It wouldn't take you that long even if you tried them all out. And now for the last one here, Leanne is driving on the highway. In 60 minutes, she drives 60 miles, okay? Now it says here we're going to let X represent the number of minutes. So in a chart, if I do XY, if X is the minutes, I'm going to put minutes on this side. And it says Y is the number of miles, so I'm going to put miles over here. Now the ratio given, 60 minutes, 60 miles. So I'm going to actually put a 60 and a 60. This time, it's only just times 1. Up here, we cut it in half. This time, it looks like it's just times by itself. So when we look at the options here, we could plug in a 3 miles, which means we'd be expecting the 3 minutes. If we plugged in a 10, we're expecting a 10. If we plug in a 15 for minutes over here, we'd be expecting a 15 miles. Looks like we're expecting the same number. So basically what we're going to pick here then is the 3 miles in the 3 minutes. Okay? So at this rate, Leanne will ride 3 miles in 3 minutes. And that means that she's going 1 minute or 1 mile every minute, 1 mile every minute. Now, if you kept watching the video, you've probably got all the answers here. There is a Google form for this. And at this time, we are done with the video. Thank you guys for watching.